Hello everyone. Today in this presentation we're going to be talking holes and hole notes. So once you get beyond dimensioning just regular features and locating features, which you do need for your holes, we do need to locate holes. We also need to define their diameter and their features. So there are a lot of different hole features and different hole types that you can see. Here in this example, you can see through the section view that there are several different types of holes. So we have through holes. So shorthand THRU just means through. A through hole means that it cuts through the entire thickness of a part. A clearance hole means that the hole is large enough to allow the head of the screw to go all the way through. So a clearance hole doesn't necessarily look any different than a regular through hole, but the design is made for a screw to go all the way through it. It's not being held in place. It's just a clearance for the entire nut, bolt, screw, whatever, to go all the way through it. A blind hole is a hole that does not cut through the entire thickness. It's called blind because you can't see it from the other side. A countersink means that there is a cone-shaped recess around the surface. It's meant to accept the head of a tapered screw. A counterbore hole has a cylindrical recess around the hole at the surface. This is usually to receive a nut or a bolt without having it protrude above the surface of the part. If you have a really shallow counterbore, it's sometimes called a spot face. A tapped hole means that it is a hole that has internal threads cut into it. So that way you can thread in a nut or a bolt or a screw of some sort. When dimensioning and creating the hole annotations, the note symbols that you'll see is we have the diameter symbol, the kind of a U-shaped, squared U-shaped looking symbol is the counterbore or spot face. The countersink is a V shape, and then the arrow pointing downwards is the depth symbol. So when we're making hole notes, we put all that information up against a leader line pointing to that hole. So here you can see in this example, we have the diameter of the hole is given first. So the diameter of the hole itself is 0.25, and that hole is 0.75 deep. So first we have the hole information, and then if there's an additional countersink, counterbore, or thread information, that comes after the hole itself. So you can see the counterbore, it has its own diameter and its own depth as well. Here in this example, we have a diameter and a depth. There is no additional information needed. And if you have a hole that goes all the way through, you don't need to identify how far through. You just go ahead and write THRU, indicating that that hole is all the way through the part. Here's another example using a countersink. So the countersink symbol comes after the designation of the diameter and the depth of the hole itself, and then we have the countersink information afterwards. When giving that countersink information, we need the outside diameter of the countersink as well as the angle that that countersink is created at. Thread notes. If you're using threads that are for tapped holes, there are two different methods of identifying thread information, and these designations are based on the measurement system you're using. So if you're working in inches, you're going to be using the Unified National Thread Method, or if you're working in metric, it's going to be the ISO method. So you can see the top example, we have a 5/16 hole that is 18 UNC. That refers to how many threads per inch are on the hole. So if you were to measure a linear inch on that hole, you would be able to count 18 threads. UNC stands for Unified Nominal Coarse. So it's a coarse threaded screw or bolt that would thread into that hole. The bottom example, in that case, we have a different look to the note because it's in metric. Metric threads are identified a little bit differently, so M stands for metric, and then we're going to be working with millimeters, and the sizes are a little bit different. So these are the same types of information that you would see if you go to a hardware store and you walk down the aisle and you look at the information on the packaging for the nuts and bolts that you could buy in a hardware store. So you can see again the diameter is given first with the Unified National, and the threads per inch is the second number, and then it always starts with UN, and then C for coarse, F for fine. There's also EF for extra fine. Those aren't as common, but that exists as well. And then for the metric system, we have M for metric, and then we have the diameter of the hole that's being tapped in millimeters. And then the 1.5 is the pitch, or the angle of the threads. And then we have some additional information. The grade of tolerance refers to the quality of manufacture, so the amount of space that's allowed between the bolt that's being threaded in and the threads themselves that are tapped. The allowance gives you an identification for how tight those threads are going to fit. And then the last thing that you see on there is whether or not it goes through, or LH could be there for left-handed threads in case, and the left hand could be in either the ANSI or the ISO. So those are the things that you'll see with holes and thread notes. So once again, if you have any questions, please ask. Otherwise, there's a lot of information on this in your textbook too, so it's always important to read the pages that I have assigned in the textbook as well.